Okay, now we're recording. Thank you so much, Micah. Okay, first thing I'm going to do is, so we realize that those are the equations we need. I'm going to go find those equations and pull them. So the equations that go with what we just decided are that VB equals VA plus capital omega cross R B slash A plus V B slash A little XYZ. And then also that acceleration of B equals acceleration of A plus omega dot cross R B slash A plus omega cross R plus 2 omega cross BB slash A XYZ. Okay, so first thing I did was try to recognize what type of problem I'm working with. Yep, sorry. Continue to tell me to do that because I can't tell what's on the screen. What the heck? Oh my gosh.
To be fair, the document is very big. So it might just be upset that you're trying to make a new page.
Yeah. Okay, there we go. I've got it on page now. Sorry, managing 3 different screens is a lot. Okay, so I figured out what type of problem it was. I grabbed the equations that go with that type of problem. And then what is the way that I always do things? After I have a set of equations, I then do what? I go variable by variable, and I find each of those variables, whether it's from the problem statement or I need to do a little bit of math to figure it out, or whether I get it from the picture. Okay, so now what we need to do is, well, double check that what's on the left-hand side of the equation is actually what the question is asking me for. So in fact, it says determine the velocity and acceleration of the ball. And it doesn't say relative to anything else. So it means the absolute acceleration and velocity. So if B is the ball, then the left-hand side is truly what it's asking me for. Okay. And then these equations are written in terms of A's and B's. And I was given that B is the ball, but what the heck is A?
The stationary reference frame.
Close.
The axis of rotation.
No. It's the origin of your moving reference frame. Okay, so let's just remind ourselves. Reminder that B is the ant, and in this problem that's the ball, and A is the origin of the moving reference frame. Okay, I haven't set a moving reference frame first. Jesus. it re-scrolled without my telling it to. All right, sorry. We haven't set a reference frame yet. Okay, so here's my indicator to think, oh, right, these set of equations want me to have 2 different reference frames. So let's go ahead and try to figure out what are the reference frames that I want. All right, so the ball here is moving beautifully relative to this purple XYZ axis that was already given to you in the problem. And that origin is smack dab on the axis of rotation of that straw thing. And honestly, I think that's a really good choice for where we should place our moving reference frame. So when I say our moving reference frame, what object am I affixing this frame to? No. The ant doesn't get a frame. The frisbee gets a frame. The frisbee gets the frame. Yep. And so the rigid body that's in here, it's just rotating. It's doing fixed axis rotation, but it could have been potentially translating and rotating. And so I think I drew it in red on the notes. So I'll just go back over and reaffirm that this we're gonna choose this as little x, little y, little z, and this frame will be fixed to the straw, meaning that it rotates and translates with the straw. Okay, and then if we back up one more, we have a choice for where to put our big non-moving stationary reference frame. And honestly, I have no reason not to put it at exactly the same location and orientation as my moving one. I just need to recognize that it is not spinning or translating with the straw. It stays completely fixed and the straw moves relative to it. Okay. Question?
For the acceleration equation, is it 2 times omega cross VB, like 2 times the like entirety of it, or 2 omega cross?
It doesn't matter. It'll work out the same. Yes.
Is there like a way you would recommend doing it, or a way that makes it easier? Like when you do it, do you double omega, or do you do omega cross V of A?
I think it just depends on how I'm feeling. I don't think one way is particularly easier than the other because at the end of the day, it's just a scalar. Okay, so this will be big Z, big Y, big X, and it will be at that same origin. Okay, so now let's go item by item and we'll start with velocity. Tell me the velocity of A. What was A again? We didn't put it on here. A is the origin of the red frame. Why?
Because it's on like the axis rotation, so it doesn't translate.
Absolutely. Yep. Okay. What is omega? That's the amount. Yep. And so if I do my right hand rule and I curl it in this arrow, my thumb points in the positive Z direction. So that's going to be 3 K hat. Beautiful. And so remember, omega here is the angular velocity of the red frame, okay, which is the same as the angular velocity of the straw or the tube. And then what is R B slash A? So let's be careful about what direction it points. So it goes from A to B. So absolutely points in the positive I hat direction and it goes 2 feet.
Okay, and that's in relation to the reference frame, not the fixed frame.
Point A
So
is the origin of the moving reference frame. Yep. Yep. Okay. Any other questions about that value? Ugh, you didn't tell me this time. Sorry.
Does it like keep zooming in on you?
It does. I don't know why.
Huh.
Maybe it likes that. Is that too tiny for you?
I didn't
Okay.
mind it zoomed in.
Okay. Well, you couldn't see what I was writing. It was so zoomed in, you weren't seeing the bottom. Okay. All right. Then V B slash A, little x, little y, little z. What's this one? Yep, it looks like 5 feet per second, but in what direction? I have, yeah. Okay, so let's go back to saying this in words. So this is the velocity of B relative to A in term as viewed from the rotating reference frame, little x, little y, little z. Okay, so it is the very simplified form of the motion of B. It's only that simple if you are observing from the moving reference frame. If you're observing from the inertial frame, the big frame, the motion gets really complicated. But for the little frame, the little x, little y, little z, I'm just moving in 5I. Okay, I'm going to stress something that I didn't stress in class because it gets very confusing. Notice that I wrote all of these in terms of little coordinate directions, little x, little y, little z. I could have written them in big X, big Y, big Z, and it would have been equivalently correct. Especially because the way that we have it drawn, they are the same directions. But even if they weren't in the same direction, I could still write them in terms of big I hat, big J hat, big K hat. The problem is that we need to make sure we're using a consistent coordinate system so that when I go to evaluate everything in this equation, I'm always adding little I hats to little I hats. Gracious.
I'm like,
Why would it do that?
I don't know if you clicked something, but it like immediately went back to Zoom.
Yeah, I know. I clicked 100% because I thought maybe it would stay there. Maybe fit to window. Okay. You just have to make sure that you're not combining across different coordinate directions. So if these two coordinate systems were not the exact same as each other, and the big coordinate system was maybe tilted or something relative to the little coordinate system, I could not combine little i's with big I's because they would be pointing in different directions. Okay, so I like to write everything relative to the moving frame if at all possible. It usually works out simpler that way, specifically because this one is usually a very simple movement. I hope I didn't waste anyone on that. Yeah, Robert. You could. Yes, absolutely. Yeah, you would do the same coordinate transformation steps that we did for like the car problem on the exam. Yeah. Very good. Okay, so I think now we have enough to find velocity, so let's plug and chug and figure it out. So VB equals 0 plus 3K cross RB/A is 2I plus 5I. Is that right? I think so. I didn't do this ahead of time, so correct me if I'm wrong. 0, 0, 3, 2, 0, 0. I minus J plus K. All right. Forward minus backwards. 0 minus 0. Forward minus backwards. 0 minus 6. Forward minus backwards. 0 minus 0. Okay. I believe this is 6J. Okay. So VB should be 5I plus 6J. Good, we got it. Questions on velocity? So hardest parts of this is probably knowing when to use this set of equations and then knowing the physical meaning of each variable. I would say those are the two hardest parts. Okay, let's do acceleration. Okay, acceleration, I need to know A. What's that? Acceleration of point A. 0, yeah, it's not translating at all. We need to know omega dot. What is that? So we're told that this thing does have an angular acceleration. Yep, 5. And then what direction? Beautiful. 5k hat. Okay. RB/A we already have. That's 2I. Just grabbing that from above. Omega we have from above as well. That's 3k hat. RB/A, omega VB/A XYZ, we have that from above. Last one is relative acceleration. Okay, in words, this is the translational acceleration of B relative to A as viewed from the red frame. Or relative to the tube.
Is it 3?
What direction? I hat, yeah. Beautiful. Excellent, that's it. Kind of. Plug and chug. Okay, I'm gonna grab this equation again because I do not have it memorized. Okay, acceleration of B equals 0 plus 5k cross 2I plus 3k cross, did I already do omega cross R? Somewhere?
It was 6J.
6j, yeah. Okay, so let's not do that again. We'll do this 3 cross 6j plus 2 times 3k cross 5I plus 3I. Yeah. Okay. Looks like we got 3 cross products. 1, 2, and 3. Zero, 5, 2, 0, 0. I minus j plus. Okay. Forward minus backwards. 0 minus 0. 0 minus 10 is the backwards. 0 minus 0. Looks like 10j. 2 jk 0, 0, 3, 0, 6, 0. I minus j plus. Okay. All right. 0 minus 18. 0 minus 0. 0 minus 0. Minus 18i. Probably shouldn't tell you this, but if you have like a TI calculator, you can do all these cross products in your calculator.
I was actually gonna ask you, if we have like, if you wrote a
Yeah.
program to cross, is that like totally okay?
You don't need to write a program, it's built in.
Yeah.
Is it tricks or something?
Something I don't know how to do it, I just know you can. I used to know how to do it on like an 84, but those are like extinguished bricks now. Yeah, but I do it by hand just because some people can't afford that type of calculator. So I go through the cross product so everybody gets the repetition. Okay, sorry. 3, 0, 0, 0, 3, 5, 0, 0. Minus j plus. Okay. You double check it. Yeah.
Okay.
0 minus 0.
Shouldn't it be 6 cross 5?
I put the 2 on the outside. I was gonna do it later.
Okay.
But you know what? Is that Samuel?
No,
No,
it
it's
wasn't.
Zane.
Oh, sorry, Zane. Can you do it the other way? Can you do the 6 cross 5?
Yeah, I did it. I was just gonna wait to see if we got the same answer.
Beautiful. Yeah, I would like to double check that.
Okay.
0 minus 15. 0 minus 0. 15J. Okay, so now I'm going to plug in acceleration of B equals first cross product 10J plus second cross product minus 18I plus 2 times my third cross product. Did you get 30J?
I did. Yep.
Oh, beautiful. Okay, just to confirm.
Yeah,
you
thank
know,
you.
Very sure. You can do it both ways. Okay. Okay, so what are all my J's? It looks like 30 plus 10 is 40J. 15 minus 15I. Let me double check. Yep, we did it. Okay, I'm gonna go back and box my answers just to make the grader happy. All right, questions. Ooh, goodness. Questions. Okay, let's choose another one and you can do it a little bit more independently and then we'll check it together. Sorry, y'all on Zoom, it's the people in class are gonna get to choose. Holler when you want me to stop.
This one.
This one?
Yeah.
Okay, sometimes I also try to look at how much work goes with it. This might be a little bit more of a simple one. So maybe although it has. Oh, it wants. Yeah, it kind of draws on 2 different problems. It might be a little messy. Whoa. That might be a better. That looks fine.
Can we like? I think we should do this one regardless, but I don't think I'm ready to take this one.
All right, then this is perfect. Y'all, I'll copy it onto my iPad and then you attempt it until you get stuck. Yeah, and then we'll come back together to get unstuck. Yeah. Come on. There we go. Crop. Just the problem. Imagine doing it in front of 95 people.
Oh, your drawings are like, your drawings are very decent. Like,
They're, well, I mostly try to do them when I'm not in front of 95 people.
Yeah, exactly.
It's a
everything
talent.
lines up, like what?
It's a talent. All right. All right, friends. Take 10-ish minutes and then we'll come back together and go from there. I'm gonna use the restroom real quick.
This question isn't posted anywhere, right? So that's.
Yeah, it should. I don't think it's in the book, but I don't think anything's posted.
That arrow's going clockwise, right?
Which one? This one?
The omega arrow.
Yeah, it looks clockwise to me. It is definitely clockwise. Oh, I like this one.
And you said it was clockwise for rotation.
Yes. Okay. How did you feel about the last one? Lost there too? Okay. All right. I would go back to the last problem. Figure that one out first. This one's gonna be a little bit.
Should I set the? Like, so the point A would be like the and, right? Or,
The water particle at point A is the, that's correct. Yeah.
but so we already give us. That leaves at a velocity of 5.
In that direction. Yes,
So we're just finding.
but that's relative to the impeller. Oh,
Oh, yeah, both, both measure both along the plate line.
yes, okay, yeah, so that's giving you the relative velocity between the ant and the.
So that would be like B.
Yes, in the little last one.
What would R B of A be?
R/B/A is the,
Is it just a unit vector notation? Or?
So like 30 sine
no,
J.
it's the full distance. So this is the vector that goes from the origin of the little frame to the particle at A. So it goes from 0 and it goes up 0.3 meters in the little j direction.
Oh.
Yeah,
Yeah.
yeah.
Makes sense.
So it's from fixed frame to unfixed frame.
No, You tried to put the little frame at the ant. The little frame goes on the frisbee.
Little phrase.
The little frame goes at the origin. At
Okay.
the center of the,
Well, I would draw them as the same at the instant show. They're not equivalent because the big frame doesn't spin with the
Yeah.
impeller.
But they're both at that like.
I would-
Central.
You can put them wherever you want, but the best choice is to put them at the center of the impeller.
Okay,
Okay, so,
and that's the center of the circle.
okay, so
Okay.
for this, you're saying water is at point A?
Yes, the water
Oh,
is at
okay.
point A. So so what is, in our analogy, what is the water particle?
The ant.
That's the ant, yeah. Okay. So then labeling it A, you need to take over that labeling, say, I don't wanna call it A, I wanna call it B, because it's the ant.
No, I thought the water was at, like, labeled B. And then-
No,
Okay, yeah.
It's just saying that the velocity of the water
It's in
relative to
that-
the.
It's in that direction.
It's in that,
Okay.
so B, they would actually just zero.
yes.
Okay.
Yep.
So what is it solved? It's just completely-
So do you see why, I may be out of line a little bit. The two hardest parts of the problem. One, recognizing that this is the set of equations you need to use. Honestly, probably the harder part is recognizing where to put the frames.
Yeah.
That's what I.
Yeah,
It's
that-
the whole A
That's
and
why-
B for me,
Yeah,
like
okay,
where
yeah.
A and B were.
Oh,
Yes.
just as it being, but probably should like have that immediate instant that.
Yes,
Okay.
yes.
Yeah.
Yes, they're telling you that at the moment shown, the water particle is moving at a velocity along that line between A and B. So what they're telling you is that this is V B slash A relative to little x, little y, little z, is that vector. They also tell you the acceleration also moves in that direction. Does that make sense? Okay. All right, we got about 15 minutes left for us, so I'm gonna go ahead and start filling in my version. If you are working and comfortable, keep working, don't look up. If you're completely stuck, maybe follow along.
No, I was in degrees, but that would have been really unfortunate.
No. Oh, wait. Sorry. I think it's probably safe. Yeah, constant, sorry. I'm sorry. So alpha is 0. Or theta dot. Omega dot. Good God. Positive 4.5 I hat. Yes. 30 meters per second squared. Okay, let's do acceleration. It's right here.
was just thinking. Fix that X with this first person.
Minus 15K cross, what did I get for omega cross R? I think it was 4.5 I. Gross. Okay. All right, only two cross products, but one of them is gross. Minus 67.5 J. Is that right or no?
Well, we don't have the same answer, so it's who is right and who is wrong. I got negative 67.5 somewhere in my answer.
Okay, that's great.
So you can be on a good path.
Okay, all right.
I don't know, I think I'm right. Not gonna lie.
Confidence. Okay. 0 minus 0. Wow, poop.
What do you have this year out? Alpha, no, TNA's alpha constant, so it's 0.
So 187.5 I.
Because it's the K hat, so it's backwards. You set up that cross product. 0, 0.
Positive, negative, positive.
Let's see, minus 50.
You know what?
No, I did get. Is that a 24 or 74?
Where?
For the 324.75. Like
324.75. Yep. I could be wrong.
So could I. I'm gonna bank on it.
You forgot to multiply by 2, I think.
Oh, poop.
What did you get then?
What'd you get?
649.5.
Heck yeah.
Well done.
Thank you, sir. You ready? Great start.
2 more minutes. Okay. Okay, so I's would be 2 times 187.5 minus 25.9.
The 187.5 should be multiplied as well.
I did.
Oh, sorry. I thought it. Never mind.
Did you get 349?
No,
I-
I got 375.
Wait. 2 of us are getting 349.02 I. 3 of us are getting that.
I also got 375 though.
How are you getting 375?
You guys didn't subtract the negative.
Did you
25.
subtract this one?
Where can you
Because I got 375 I
Yeah.
had from the cross product, but if you don't take the 30 cosine 30 the acceleration term for I hat.
I'm gonna do my math again.
I forgot to do A acceleration.
597, Jay.
Yes.
Okay. Let's check the guide. 349 I, 597 J. Yep, we got it. Don't forget to multiply by 2. And this is meters per second squared, right? Yep, it's all in meters.
So is that one document?
Oh, I just made a simple mistake. Sorry about that.
All good. Sorry, Andrew. what?
Is that one document all of the notes you took in our class?
Yes. I'm pretty sure like 99.9% of it is uploaded
Yeah, that's all.
in just separate documents. Okay, I'll upload this file as well so that you have 2 more examples of these problems, okay? All right, thanks for joining. Please email if you have questions. Thanks everyone on Zoom.
Thank you.